Gyronics.
Okay, so we have a quite challenging problem here. A circular piece of filter paper, r inches in radius, is folded twice. First on diameter and then on the radius perpendicular to the crease. So it is then opened up as to form a right circular cone. So find in terms of r the volume of liquid it will hold. So we are going to calculate for the volume of the cone in terms of r, or the radius of the original piece of filter paper. Okay, so let's visualize this problem. So first, we have a circular piece of paper with radius r, and the circumference of this piece of paper is given by this formula. Of course, C is equals to 2 pi r. So the next step is to fold this piece of paper on the diameter. Okay, so let's fold this paper. Okay, what happens to the circumference now? So from 2 pi r, it will be half, given as pi r only. So next is it will be fold along the radius. Okay, so let's fold this piece of paper along the radius. So what happens to the circumference now? So the circumference of this paper now is 1/2 of pi r. Then it is opened up to form a cone. So what happens to the circumference of the base now? Take note, this is a flat surface. So this length is 1/2 pi r. So where it is in the cone, this is 1/2 pi r. Of course, at the back, another 1/2 pi r. So the circumference of the base is, of course, twice of 1/2 pi r. We have pi r. So this is the circumference of the base. Next, to calculate for the volume, we need the height and radius. And to determine that height and radius, we need the right triangle for this one. So this is the height and this is the radius. The base of this cone is given by the circumference, which is pi r. That is in terms of the original radius r, so capital R. We have another radius which we labeled r, this one, the lowercase r. And we can also find the circumference of the base using that lowercase r, given by this equation. Of course, C equals 2 pi r, which means this 2 pi r, the lowercase r, is also equivalent to this one, pi r. So we can equate both of these equation, and of course we can cancel out the pi. So we can have the relationship of the lowercase r in the uppercase r. And again, take note, this r is the original radius of the piece of paper. So r divided by 2. Next, we need to express also the height in terms of uppercase r using the Pythagorean theorem. So we have r squared, that is the hypotenuse of this triangle. So equals r squared. Okay, so this is the A, and let's say the B is h. So we have plus h squared. Take note, your lowercase r is also equivalent to r over 2. So let's substitute that value. So we have r over 2 squared plus h squared. Okay. Then let's square this term. So we have now r squared equals r squared over 4 plus h squared. So let's calculate for h squared. H squared is, transfer this r squared over 4 to the left side. So r squared minus r squared over 4. Okay, so this is 1 minus 1/4. So h squared is 3r squared over 4. Of course, h squared transfer to the right side will become square root. So square root of 3r squared over 4. So h is r square root of 3 over 2. So square root of r squared is r, so we can take that outside of the radical sign. Square root of 3 remains. Square root of 4 is 2. Okay, this is now the value of the height. And we can calculate now for the volume. We have the height, we have the radius. Using this formula, 1/3 of pi r squared. So let's use this equation to the problem. So we have 1/3 pi r squared times height. So volume equals 1/3 of, okay, so we'll be using now the uppercase r. So r over 2 squared times height, which is r square root of 3 over 2. Okay, so volume is 1/3. So square this term. So this is r squared over 4. Okay, pi r squared over 4 times r square root of 3 over 2. Okay, so 1/3 times 1/4 times square root of 3 over 2. And this one, r squared in r is r cubed. And the final answer for the volume of the cone in terms of the radius of the piece of paper, r. So we have pi square root of 3 over 24 r cubed. Okay, so quite challenging, but always remember in every problem there is a solution. So see you on the next exercise.